What we're going to look at today is how do cells take a food item like ice cream or an apple or anything and get that food item into the cells. We have learned already that the cell membrane only lets certain things in and out, and many times it's based on size. So these food items are way too big to fit in. So what the cell is going to end up doing, or the body is going to end up doing, is breaking these up by using some type of cutting technique. And that cutting is going to be occurring through enzymes. So let's take a look at dairy products as an example. You probably have heard there are certain people out there, and you might be one of them, that cannot eat milk products. And what we end up calling that is lactose intolerance. So what the heck is lactose? Well, oftentimes when we see the OSE ending, that means it's a sugar. And lactose is really just a fancy way of saying milk sugar. So people that are lactose intolerant, they struggle with breaking down lactose. So they don't have the enzyme called lactase that can't cut up the lactose to produce the two simpler sugars, galactose and glucose. So if you are lactose intolerant, you don't produce that lactase enzyme, or not enough of it. And we also see that there are certain types of cultures out there, certain groups of people that have a higher rate of lactose intolerance. So the best example I would say is if you look at Chinese food, there is very little, if any, milk products in Chinese food. And you might not have noticed that. And the reason being is that people of Asian descent typically are lactose intolerant. So they're not going to be putting milk products into their dishes. There are ways to get around that. They do offer medicines, which is, in this case, there's Lactaid. And all that really is a chewable tablet that has the lactase enzyme in it. And then it allows the person to be able to eat some lactose-filled foods. So what is actually happening? You have an enzyme, and this is Ernie the enzyme, and then we'll have that substrate, which is, let's say it's the, we'll say it's going to be the lactose. So this enzyme is going to fit into the substrate, or that milk sugar, and it is going to break it up into two pieces, and that's going to be called products. And the enzyme is very specific in what it connects to. So each enzyme here is specific to the type of thing that it's going to be taking apart. Now, enzymes don't just take things apart, they can also put things together, so they have many, many uses within the cells and within your body. So certain things can speed up or slow down the effectiveness of an enzyme. And what I'm going to show you now is an apple browning demo. And if you've ever noticed that when you cut a apple up, and if you don't eat it right away, you're going to see that it just starts turning a different color. And what's actually happening there is there's an enzyme that's being released, and that interacts with the oxygen of the air, causing that apple to turn brown. So the demo that I'm going to set up is going to show the effect of pH and the effect of temperature on an enzyme. Now, pH is just a fancy way of saying how acid or basic or neutral something is, and the temperature is exactly what you think temperature is, how hot or cold something might be. So let's take a look at that. So to run this lab or mini demo, whatever you want to call it, you just need an apple. And so we'll cut this apple up, and the apple cutting technique I actually learned from my mom. This is how I've always cut an apple, is just decore it this way. And so I'm going to try to get some equal-sized slices. I'm going to do 4 different ones, and I'm going to put one of these slices into my freezer, I'm going to put the other one into my toaster oven. I'm not going to toast it, but I'm going to make it pretty toasty. And then the next one, I'm going to put some acid on it. And then the last one is going to be my control. I'm going to do nothing to it. And we've talked about control groups before, and they're important because you want to be able to compare the results, or what's happening in your experimental group, to what you've done. If you don't have that control, you don't have a comparison to know what's happened there. So this is the acid that I'm going to be using. It's just lemon juice, and I'm going to dump a bunch of it, probably a little bit too much here, onto the apple, and I'm going to smear it around so I get complete coverage of this lemon juice all over that apple. Anyone that makes fruit salad probably knows the little trick of either putting some type of lemon juice on fruit that normally browns, or you can put some Sprite or some other type of acid on there, and it should stop the apple from browning. So now I'm going to do a time lapse, and you can see that control really starting to turn brown, and the acid doesn't look like it's done anything. And again, that's because the acid is preventing that enzyme from doing its job. So now I'm going to bring in my other results. The warm one got brown, but not as bad as the control, and then the cold, it looks like nothing happened to it. Now the cold doesn't change because the enzymes slow way down, so they can't make the apple brown. And the warm, it might have changed the shape of the enzymes, so they couldn't work. So that was the apple browning lab. Okay, so if I were to graph the effect of temperature on this apple, I would see that the temperature does have an effect on this apple, and it seems that as the temperature goes up, it starts to turn brown quite a bit, and then as it furthers its temperature, it doesn't turn as much, it doesn't get as brown. I actually put the apple in the toaster oven to get to that point. So that's showing you the effect of enzymes. So the optimal temperature for that enzyme to work, in this case, is going to be about 70 degrees Fahrenheit. Now, pH, what I've got here is a graph of, say, what pH effect would have on this enzyme. And if you look at the lower the pH, which was the lemon juice, which is going to be actually less than 5, the enzyme did not work. And as we increase that pH, you're going to see that the enzyme starts to work better, and it works best at a pH of 7. And then as it becomes more and more basic, it doesn't work out as well. So that's just showing you how an enzyme can be affected by temperature and how an enzyme can be affected by pH. So I hope that makes sense. The next class, what we're going to do, or the next video we're going to look at, is if you've ever looked in the back of a Jell-O packet, it's going to say don't ever mix pineapple or papaya, or I think there's a couple other fruits in there, and we're going to explore why that is, and it has to deal with enzymes. And to give you a little hint, here is my Jell-O, there is my enzyme, and that's what happens to my Jell-O. So until next time, see you guys.